Hi, in this video we'll learn how to trace the recursive function and how to write a recurrence relation and how to solve a recurrence relation. So I am taking one of the example, then in the other videos you can find following examples. More examples will come in other videos. Let us start. Already I have an algorithm, a function here, a C language function I have written. You call it as algorithm also. Test is a function which is taking n as input, and if n is greater than 0, it is printing the value and then it is calling itself for n minus 1. So I will take some sample value and test it. Suppose I am calling this function by passing 3. Let us see what happens if I pass 3. Test 3. 3 is greater than 0. Yes, 3 is greater than 0. Print 3. So it will print 3. Then call itself for 3 minus 1, that is 2. So call test 2. Then for 2, again it's a recursive call. So for this call, it will print 2 and call itself for 1. 1 is greater than 0. So it's a recursive call. Again for this one, as it is greater than 0, it will print 1 and call itself for test 0. Now when it is 0, 0 is not greater than 0, so it will not call itself and it will stop. Doesn't go further. So this is a tracing tree for this particular function or recursive function. I have passed 3. So what is the time taken by this one? So let us see what it is doing. In this call, it is printing a value, then calling again, printing a value and calling again, printing a value and calling again. So the amount of work done is just printing value. How many times it is printing? This is the major work done by this function, printing a value. How many times it is doing? 3 times it is doing, as I have passed 3. How many times it is calling itself? As I have given 3, it is calling itself for 4 times. Now, what is the time taken for printf? It is just 1 unit of time. Just it is a single statement and simple statement. It is taking 1 unit of time. If I say 1 unit of time, then in each call, it is spending 1 unit of time. That is printing and then calling. So 1 unit of time, 1 unit of time. So total how much time it has taken? 3. If I take number of calls, then there are 4. That is 3 plus 1. It means if I pass 5, then it will be 5 plus 1 calls, and 5 is the number of time it will print. So if I pass n, then total how many calls it will make? It will make n plus 1 calls. N plus 1 calls. And how many times printf is executed? N times. If I approximate the amount of work done depends on the number of calls, if I say. Like in the last call it is not printing, just ignore that and say that for every call it is printing. So the time depends on what? It depends on the number of calls. So how many calls it will make for any n? It will make n plus 1 calls. So the time function, if I write f of n, then it is n plus 1. Then what is the time complexity in notations? It's order of n. I can use big O of n, theta of n or omega of n. Anything I can write there. This we have already discussed in previous videos. So that's it. By a tracing tree, I have found the time complexity of this one. You can also call it as a recursive tree or a tracing tree or a recursive tree I have used. Now let us find out how to prepare a recurrence relation for this function and how to solve that recurrence relation. Now if any function or an algorithm is given to you, you can prepare a recurrence relation as follows, like this I am showing you. Assume that the time taken by this is f of n. No, usually for recurrence relation, function name is t, that is t of n is used. So I'll use the same thing. So instead of f of n, I'll call it as t of n. Time taken by this algorithm is Tn, or this function is Tn. Then that Tn will be equal to what? The total amount of time taken by this one. So let us observe what is happening inside. Condition is checked. Let us ignore condition. Inside that printf is there. 1, it will take 1 unit of time. The next, what is the next one? It's a recursive call. It's the same thing. How much time we mentioned for this Tn? Then what will be the time for this one? Tn minus 1. Right? Now, that's it. So what is the total time Tn? I said that the total time taken by this part of an algorithm. So that Tn is equals to Tn minus 1 plus 1. Now, you can ask me why you have ignored condition. Say, if I consider that condition also for one time, then it is just one condition. So one time, then I'll get 2 here. If I take 2 also, then the result of this expression will be same only. For the recurrence relation, I'll get the same answer. So if you have any constant value, you can simply make it as 1 and use it. Or if you can write it as C also and use it, constant, or some A as a constant. Some constant also you can write and use it. So I prefer taking it as 1. So if you have more than 1, then you can round it up to 1 only. Alright. This is the way we write a recurrence relation. Now let us write a recurrence relation. Tn is equals to Tn minus 1 plus 1, this one. When n is greater than 0. Yes, when n is greater than 0, this is the time. What happens if n is equals to 0? It's not doing anything if n is equals to 0. So if n is equals to 0, it is not doing anything. So shall I write 0 here? No. The time we don't write it 0. If it is 0 also, it's a constant. So we write it as 1. So I will take it as 1. Or else you can make it as C or A or K, anything, some constant you can write there. Now let us solve this recurrence relation. Now let us solve this recurrence relation by substitution method, back substitution we will follow. Let us take this. This is Tn is equals to Tn minus 1 plus 1. We will solve this one. That is already solved, it is 1. We have to solve this one. Now for solving this, I can know the answer for Tn if I know what is Tn minus 1. So what is Tn minus 1? What is this? If I know, I will use it here. So I don't know Tn minus 1, but I know what is a Tn. Tn is equals to Tn minus 1 plus 1. Yes, this is the one. Then what will be Tn minus 1? So if this is n and it is changed to n minus 1, so this also n minus 1. So this becomes n minus 1 minus 1, n minus 2 plus 1. Okay, since this is Tn, therefore Tn minus 1 is this one. Now, substitute Tn minus 1 in this equation. So Tn is equals to, in bracket, I'll write this Tn minus 1. So what I got? Tn minus 2 plus 1 and plus 1. So this part I have substituted here at this place. So I got this one. Then this is Tn is equals to Tn minus 2 plus 2, 1 plus 1, 2. If I substitute again, then Tn is equals to, what will be Tn minus 2? Tn minus 3 plus 1. See this, Tn minus 2 will be equal to Tn minus 3 plus 1. Yes, I have substituted this portion here, right, at this place. So I have written this. Then plus 2 is as it is. Now if I solve this one again, then Tn is equals to Tn minus 3 plus 3. That's what I got. So how many times I should do this? See, when I got 2 times, that is sufficient. You can continue further. And I say that I am going to continue this. How long? For k times. Continue for k times. If I continue for k times, what I get? See, if you observe, when I did for one time, it was 2, next time it was 3, then it goes on, so it will be k. So this will be Tn is equals to Tn minus k plus k. So this is the important one for me now. I'll continue here. What is the equation I got? Tn is equals to Tn minus k plus k. See, it was Tn minus 1 plus 1. Substitute it, I got Tn minus 2 plus 2. Substitute it, I got Tn minus 3 plus 3. Continued up to k, so Tn minus k plus k. This one. So I said that I will stop at k. K means some steps. After some steps, I will stop. After k steps, k substitutions, I will stop. Now, what is the smaller value I know? I know n is equals to 0. If n is equals to 0, I know it is 1. Answer is 1. So here, n minus 1 was there. So minus 2, then 3, then 4. If you go on subtracting like this, at one point it should become 0. So my purpose was to go on substitute and reach till n equal to 0. So I assume that I have reached at 0. So I assume this n minus k is 0. I'll assume this. Means I have reached till there. When I say n is minus k is equals to 0, therefore n is equals to k. Then what this will be? This will be Tn is equals to Tn minus n plus n. Then Tn is equals to, what is this? T0 plus n. So this is, what is a T0? T0 we already know it. It is 1 plus n. That's it. It is solved. What the answer I got? You see, 1 plus n is the time. So just now I have shown you how we can prepare a recursive tree and find the time for that algorithm. Actually, I made a tracing as well as along with that recursive tree. So there also I got n plus 1 calls. Here also I am getting the answer as n plus 1. So I have prepared a recurrence relation, solved that recurrence relation, and I got this answer. And this is again order of n. See, actually this belongs to a class, linear class, order of n, that is n. So I can call it as theta of n. That's it. This is the first recurrence relation. So I'll show you more and more recurrence relations. So I'll take the program, I will prepare the recurrence relation and I will solve it. So continue watching rest of the videos.